Now, what happens if you put an electrical appliance in a circuit? Well, you can put anything in a circuit, such as a light bulb, and it's going to act as a resistor. When you put anything in a circuit, such as a light bulb, like I say, it acts as a resistor, and if you put one in here, it was going to cause resistance to the flow of electricity. What you find is that the voltage will remain the same, but less current will flow due to the extra resistance, as the electrons not only have to travel through the wire, they've got to go through the light bulb. So anything you put in a circuit is basically putting in, it's like putting in a resistor. So, how do you determine the current in a circuit? Well, this here is the formula here, which can be used to determine voltage, current and resistance. So you need to remember this formula. V equals IR, where V is the potential difference, or the voltage, I is the current, which is measured in amps, and resistance is measured in ohms. So that's the V equals IR. Now this can be transposed to help you determine the resistance in the circuit if you know the current, and obviously this here transport here is R equals VI. You see, you can transpose it to either determine the voltage, the current or the resistance. Let's do an example then. If a potential of 6 volts is provided in the circuit with a resistance of 0.1 ohms, in other words the resistance is purely caused by the wire, very low resistance, what current will be flowing? Well, this is a formula, V equals IR. Transpose it to work out I equals V divided by R. Put known values in, I divided by 6 divided by 0.1 gives a current of 60 amps flowing in the circuit. So there'll be 60 amps flowing in there because it's got low resistance. Now, what would the current be if you put a light bulb in the circuit with a resistance of 5 ohms? Yeah, 5 ohms. You put that in now. Now the resistance would be 5.1 ohms. Put this in the formula, it gives a current now of only 1.18 amps flowing in the circuit. Can you see how putting resistance in a circuit by connecting a light bulb or a toaster, for example, will reduce the current in the circuit because the potential difference is required to force the electrons through the resistance? Let's do another example. If a potential of 12 volts is provided in the circuit with a resistance of 0.5 ohms, what current will be flowing? Well, this is the formula, V equals IR. If you transpose it, you get I equals V divided by R. Insert your known values, I equals 12 divided by 0.5. It results in a current of 24 amps. Let's do another example. 2 4-volt batteries are provided in the circuit and the current flowing is 6 amps. What is the resistance of the circuit? Well, this is the formula again, V equals IR. If you transpose it, you get R equals V divided by R. This time it's R equals V divided by I. If you insert the known values, R equals 2 times 4 divided by 6, it tells you the resistance is 1.333 ohms.